Let us understand how to execute SQL scripts using pSQL. As part of the previous topic, we have seen how to create a database and a user. Now we will be seeing a bit realistic dataset, and we will see how to ensure that the tables are created as well as the data is loaded into the tables that are created in the database. For this purpose, we will be creating a new database and then run the scripts which are cloned from GitHub. First, we will be cloning the GitHub repository onto the host. Then we will copy the folder which contains scripts to itv_pg container under root folder /. Make sure retail_db database and retail_user are created. Then we'll actually run the appropriate scripts to create tables as well as to insert the data. Then we'll validate that tables are created and data is inserted by running simple queries. So on Ubuntu based VM which is provisioned from GCP, we can run this command to clone the repository. If you are in a different directory than your home directory, you can always run this command called as cd to go to the home directory on the VM or the server on which you are trying to set these things up. So in this case, I have to connect it to the web console. I can say cd to ensure that I am in the home directory. Then I can run this git clone command, which will ensure that the retail_db repository is cloned from GitHub to this local machine. And then you should be able to run ls-ltr retail_db. You should be able to see the files in it. Now, as part of the second step, we need to copy the script and validate. For that, you can use this docker container cp command or docker cp command. You can specify the retail_db either using relative path or fully qualified path. If you want to use the relative path, this is how the command will look like. Docker container cp retail_db itv_pg:/. If you want to specify fully qualified path, you can actually say /home/dgaddiraj, which is my user account in this case, and then you should be able to specify retail_db like this. It will take care of copying the folder into the root folder in our itv_pg, which is nothing but the container. Now you can actually validate by running these commands. This will take care of checking whether the retail_db on the container have the files or not. I just have to go to the web console and have to paste this. You can see that there are a bunch of files. We should be able to run these scripts once we launch the pSQL. The way you can launch the pSQL is by using this command. It will take care of connecting to the pSQL on the container. So in this case, I am going to the web console and I am pasting this command. It will take care of getting into the Postgres that is running as part of the container. Now, as we are in the container, we should be able to create the database by running these commands. In this case, I am creating a retail_db database, retail user with password retail_password. In our case, try to use a different password than this so that people cannot guess and hack into your system. Once you create the database and the user, you should be able to grant the permissions on the database to user using grant all database retail_db to retail_user. Now I can actually go to the web console in which we are already connected to Postgres, and we should be able to run these commands to take care of creating the required database as well as the user. You should come out of this because you should validate as retail_user. To connect to Postgres as retail_user, you can leverage this command. It will take care of connecting to the database using retail_user username, and we'll be connecting to the database retail_db directly. If I copy paste this as part of the console here, it will take us into the pSQL once we enter the password, and we are in the retail_db database within the Postgres. Now we should be able to run the scripts using /i. The scripts are under /retail_db. The script which will facilitate us to create the tables is nothing but this one. You can copy paste this like this, and you can see that all the tables are created. You can also say /i/retail_db. You can also autofill by just hitting tab. This is the script which will facilitate us to load the data into the tables. It will take care of loading all the 6 tables that are created as part of the previous script. Now we got the tables as well as the data loaded into the tables. You can validate by saying /d like this. You can see all the 6 tables: orders, order items, departments, customers, categories, and products. If you want to see properties of a particular table, you can say /d like this, and then orders like this, and you can see the details. Same is the case with order_items. You should be able to see the details with respect to order_items. This is how you should be able to validate whether the tables are there with all the properties we are looking for. Now, to ensure that data is copied, we have to run some select queries. So in this case, I can say select star from orders limit 10 to see the data from orders table. You can see the data here, which means data is successfully loaded into the table. Even if you look at the output, when the script have ran earlier, there are no errors, which means data is successfully loaded But to understand how the data look like within the tables, you can run these simple queries. You can also say select count of 1 from orders like this to get the number of records that are loaded into the table. We have 68,883 rows in the table. This is how you should be able to validate whether the tables are successfully created or not. And here I have provided the instructions. You should be able to run this type of queries against all the tables. If you are interested, you can take it up as an exercise and you should be able to validate against all the tables by yourself. That being said, we have successfully created RetailDB database in our Postgres server. We created the tables, loaded the data into the tables, and also we have validated by running simple SQL queries. Make sure you follow this process to validate multiple datasets to be comfortable in interacting with the databases.